Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation with, as you can see, two different bases. So what our first step is going to be is we're going to expand our right-hand side here. We have 5 to the power of x plus 2. And remember, let's say we have a to the power of b plus c. An important property of exponents is that we can change this into a to the power of b times a to the power of c. Because remember, when we're multiplying exponents, we add these two. So all we're doing is we're simply reversing this. So that's what we're going to do to 5 to the power of x plus 2. We're going to reverse it back to its original form and expand it. So 5 in this case is a, right? So we have 5 to the power of b is x, times 5 again to the power of c, which is 2. And this is still equal to 2 to the power of x. Now, 5 squared, as we all know, is 25, right? So this is 5x times 25 equals 2 to the power of x. Now what we're going to do is we're going to divide both sides by 5 to the power of x. So if we divide both sides by 5 to the power of x, well, for this side, these two will cancel out. So on our right-hand side, we'll just have 25. And on our left-hand side, we'll have 2x over 5 to the power of x. And this can actually be written as 2 over 5 whole power x. And this is equal to 25. So now what we're going to do is we're going to take the log base 2/5 of both sides. So we're going to take the log base 2/5 of both sides. Well, these two actually cancel out because remember, the log is the inverse of an exponent. So because this is base 2/5, these two are going to cancel out. So on our left-hand side, we have x equals, and on our right-hand side, we have log base 2/5 25. And this is actually equal to, using the change of base formula, which is an important property of logarithms, log 25 over log 2/5. The change of base formula states that if we have a logarithm like this, log of this equal over, so this equals log of this over the log of the base. So now this can be converted to, let me write this over here, log 5 squared, because we're simply changing the 25 to a 5 squared, over log 2 minus log 5. Remember, when we're subtracting logarithms, we divide. So we're simply just inversing that. So log 2 minus log 5. And this, an important property of logarithms, the power property, states that we can just drop down the exponent here in front of the log. So this can equal 2 log 5 over log 2 minus log 5. And this is our answer in its simplest form. If we want a more simpler form, we need to use a calculator for that, but this is the most simplest form we can write our answer in. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have x to the power of 8 minus 121 equals 0. So what we're first going to do is we're going to add 121 on both sides to isolate x. We want to isolate x, so we're going to get rid of the negative 121 on this side. So these two cancel out because 121 minus 121 is 0, so we're left with x to the power of 8 equals 0 plus 121 is simply 121. Now what we're going to do is recall a property of exponents. If we have a to the power of b to the power of c, this is equal to a to the power of b times c. So what we're going to do is we're going to change our x to the power of 8 here so that it is in this form, a to the power of b to the power of c. So we're actually going to change this to x to the power of 4 to the power of 2. Because 4 times 2 is 8, and that's x to the power of 8. And this is equal to 121. Now what we're going to do is we're going to take the square root of both sides. So now the square root of this, well, these two just simply cancel because these two are opposites. So on this side, our left side, we have x to the power of 4. And on our right side, we have positive and negative 11. Remember, it's positive and negative, not just positive. So now we have x to the power of 4 equals positive and negative 11. Now we're going to take the fourth root on both sides. So by doing that, these two would cancel out. So we are left with x equals the fourth root of positive negative 11. So this is our answer.